Next is Nernst equation can be used for finding out the equilibrium constant of a chemical reaction and change in free energy delta G. These are the two applications of Nernst equation. Therefore, let us see first equilibrium constant, how it is connected to the Nernst equation, and how free energy of a chemical reaction, how we can calculate it. For a cell reaction, PaQB plus QB, a reversible reaction, RC plus SD, that is the stoichiometric factor. P, Q, R and S, and AB are the reactants and CD are the products. At this stage, the concentration of all the species involved in the reaction will be in equilibrium, because the equilibrium sign should be there when you derive the equation, and the cell potential will be equal to 0. That is one of the most important point. Point number 1. When a chemical reaction is in equilibrium, E of the cell is equal to 0. Fill in the blank question can be asked, and the basis for the derivation of this equation. When you listen to the audio, if you derive by yourself, you will understand more clearly. Don't copy it from here. The equilibrium constant Kc is given by, for any chemical reaction, the equilibrium constant Kc is the concentration of the product raised to the power of its stoichiometric factor divided by the concentration of the reactant raised to the power of its stoichiometric factors. Therefore, Kc is equal to C raised to the power R, D raised to the power S, and A raised to the power P, and B raised to the power Q. Therefore, Nernst equation can be modified as E of the cell is equal to 0 because it is in equilibrium. E0 of the cell can be determined from the electrochemical series minus 2.303 RT by NF log to the base 10. This is Kc. Actually, we already said that what is Kc. This factor can be replaced by Kc. Therefore, 0 is equal to standard potential of the cell minus 2.303 RT by NF log to the base 10 Kc, or E0 of the cell. You just bring the E0 of the cell to this side and the minus sign will go, that is, or minus E0. Therefore, cancels the minus sign and you will get the final answer. All this you derive by yourself. See that whether you are able to get this value. E0 of the cell is equal to 2.303 RT by NF log to the base 10 Kc. From this equation, that is, this equation represents the relationship between equilibrium constant and E0 of the cell. Sometimes for 1 mark question in the section A, derive a relationship between Kc and E0 of the cell can be asked. And this equation may be used for the calculation of the equilibrium constant of the cell reaction at equilibrium. If the temperature is 298, you can substitute here and see that whether you are getting this value. For example, E0 of the cell, by substituting all these values, Faraday, that means 96,500, R is equal to 8.314, temperature is equal to 298, you should get this value. Do the calculation and see that whether you are getting this answer. Therefore, finally you can find out Kc using, that means equilibrium constant can be used, find out by as an application of this Nernst equation. And the equation 4 and 5 can be used to calculate the value of Kc at 298. That is this equation. Finally, what we derived. An assignment is given here, and try to do this assignment. All the instructions are given and we discussed it. If the answer and how to do the problem is given in the textbook, before doing it, don't refer it. After it, you just see the answer that you got is same as given in the textbook. That means you are able to find out the equilibrium constant by applying Nernst equation, or one of the most important application of Nernst equation.